Okay. So we're going to apply Hund's rule to oxygen, and so our oxygen atom is got an atomic number of 8. So we know we have 8 protons, 8 neutrons, and 8 electrons. So I've already started setting this up. So we have our 1s orbital, our 2s orbital, and our 2p orbital. So here we have in our 1s orbital 1 electron that's going to be spin up and 1 that's going to be spin down. So these will cancel each other out, giving us a net spin of 0. Now in our second orbital, we have 2s and 2p. So at the 2s level, we have an electron with spin up and an electron with spin down. So once again, we so far have a net spin of 0, but that leaves us with how many electrons? Well, here we have 2, 4. Well, we still have 4 electrons left, and we have room in our 2p orbital actually for 6. So I want to show you how these are going to fill up. Well, we're going to have, essentially, we could really have 3 pairs of electrons, right? We can have 1 with spin up, spin down, 1 with spin up, spin down, and 1 with spin up, spin down, totaling our 6. Now, but we only have 4 electrons left. So the way these are going to fill up is we're first going to acknowledge that 3 of them are going to get as far away from each other as possible. Okay. Now we only have 1 electron left, right? We have 1, 2, 3, 4, 5, 6, 7. We have 8 total electrons in the oxygen atom. So the 8th one is now going to have no choice but to pair up. So now how many unpaired electrons do we have in this oxygen atom? Well, once again, we have 2 unpaired electrons. Now, if you get later down in the periodic table, you're going to start getting into your d orbitals and so on. Those orbitals can hold more than these can, right? They can hold 10 electrons. So you have more room. So if an orbital can hold 10 electrons, let's just look at our d orbital, for example. So if our d orbital can hold 10 electrons, then really it can have 5 pairs. So these actually have the capacity, right, 5 pairs. These have the capacity to have 5 unpaired electrons. So you'll see a lot more magnetic properties when you start getting into your d orbital. Okay, so my main point here is just to say that magnetic properties arise in the presence of these unpaired electrons. Now, these unpaired electrons have a net spin. So up here, we actually do have a net spin if we're looking at our oxygen atom. The net spin here is 2, we can call it, right? So this is going to have some very, very minimal magnetic properties because of these unpaired electrons. And these unpaired electrons, you can say, are 2 electrons that are moving in the same direction. So it creates a directionality, okay? 2 electrons moving in the same direction. Because remember, we said spin up and spin down can be referring to clockwise versus counterclockwise. So 2 electrons moving in same direction creates a net polarity or a net directionality.